the first homework of last week asked you to generate a program that write a program that generates a series using a function which takes the first and last values of series and then generates n terms in between that are equidistant, whereas n is an inputted integer. So basically what you're supposed to do was you had to enter two values and the number of values that you wanted to be inserted between these two values, and these values that have to be inserted have to be equidistant from each other. That was the whole point of last week's lecture. So let me just copy this down here. Let's see how to solve this. Okay, so the first thing that we're supposed to do is we need a function. So let's just declare a function called series, and the function takes in three values, the first being the first value, the last value, and the number of terms in between. And the next thing that we do is there's actually a formula, if you've learned it in AP, which says that you calculate a d. This is the formula here, which is y minus x divided by n minus 1. And then what you do is you add this to a and say a plus d, a plus 2d, and so on. So to give you an idea of how it works, let's just take this example of 1 and 7. So if we have 1 and 7 here, y minus x will be 7 minus 1, which is equal to 6. And if you want to enter two numbers in between, it would be 6 divided by in this case would be 2 minus 1, so it would be 1, and that in that case we would be adding it. Okay, so after sorry, mistake here. So if it's 7, it would be 7 minus 1, which is equal to 6, and 6 divided by 2 plus 1, which would give us 3. So when we add 1 to 3, we get 4, and we add 3. Oh, sorry, it's 2. My bad. 3 here, and so then 1 plus this would be 2 into 2 in this case. This would be 5, and the last number would be 1. So in the end, we get a series which is 1, 3, 5, 7. So this is the formula that takes in the d. You have to add the first time 1 plus d, the next time would be 1 plus 2d, 1 plus 3d, and so on. That's how we would go with it. So the next thing that we would probably need is I would use a list in this case to store all the values, and obviously the first the series would start with the first number which has been inputted, which is x in this case. So I would start with x, and then I would have a loop which goes for I in range 1 comma n plus 1. So what this would essentially do is we just want to append x plus I into d inside this. So I into d is essentially what we computed. So the first value will be 1, which has been already inserted in the list. So next value would be 1 plus 2, which is 3, and after the loops runs, the next time it will be 1 plus 2 into 2, which would give us 5, and after that the loop would exit because it's exceeded n. Then once it's exceeded, now we have in the list 1, 2, 3, and 5, but we need to append the end value as well. So we just append y at the end, and we return a, so that the function returns something. So to call the function, all you have to do is give series and few values. Let's just say 1, 7, and 2 to be inserted. Let's give it some time to initialize and run. Cool, there we have the output. So another thing I would probably do is maybe convert everything into float so that it makes things much easier and so on. So maybe one thing that I would do. So I didn't include the getting the input part here because it's self-explanatory. I don't have to show you guys how to get input and insert it here. So you just need to type in a couple of statements to get the input and just say series x comma y comma c. That's the only change that you have to do. Cool. So going to the next program, we have to write a program to check whether a given sentence is a word chain or not. So to illustrate what's a word chain, let's just take this sentence here. A word chain is something that the first word's last letter and the word after that's first letter should match. So E and E match here, T and T match here, R and R match here, W and W match here. So that's a word chain. And if any one misses, for example, in this case, G and T do not match, so at that point it should say it's not a word chain. So the first thing that you might have the intuition that, we're checking the last letter and the first letter is essentially what they're checking. So if you think about it, the last letter gets a negative index of -1. Let's just assume that it's a string, each separate string. So E would have an index of -1 and this E would have an index of 0. T would have an index of -1, this T would have an index of 0. So it's always -1 0 -1 0. So what your first intuition would be is to get the sentence, split them, and maybe check the last letter and the first letter of the next string. That would probably be your intuition to go into solving this problem. So let's see how we do that. The first thing that we do is we get an input from the user, say enter a string, and once we get that, we want it to be split. So that's why we use the split function here to show you what the split function does. Let me just copy paste this input right here. So this is what the split function does. The split function splits the sentence between the spaces. So once the split function splits the sentences in between spaces, we get apple, elephant, and temper in each index. So now all we have to do is, as I said, check the -1 index of this and the 0th index of this to check if they're equal. So what we do is we loop through, because we need to check through each element. We say for I in range len of a -1, because you know that in this case length of a is 5, but we have to give -1 because we can't iterate over the last thing here. We can't check whether this and the next thing is same or not, because there is no word that comes after it. So we end with checking rainbow's last letter and water's first letter. So this is where the checking happens. So a of I, so in this case a of 0 would give us apple, and a of 0 of -1 would give us E, and we check whether that is not equal to, you can do it the opposite way, but I'm doing it this way, not equal to a of I plus 1, because this is a of I and this would be a of I plus 1's 0th indexed place, which is this E here, and -1 would give us this E here. And in case they're not equal, we've learned something which is, let's just say first we'll say if they're not equal is obviously not a word chain. So it's not a word chain. And at any point, if this last letter and this first letter does not be the same, then obviously it's not a word chain. We don't have to check for all this that comes after it. So the statement that's used to break out a loop is break, because we have no necessity of checking all that comes after this. So we can just stop from here. And there's another interesting function which helps us say that it's a word chain, which is the else function. So the for else block, how it works is, if the for loop runs without breaking, the else block runs. If the for loop happens to break in between, the else block does not run and it quits to the end. So when it's not a word chain, it breaks. So the else block will not run. But if it is a word chain, it is not going to break here, but the else block will run. So all we have to do is say in the else block, it is a word chain. So let's just try it out with the same input, and it says it's a word chain, just printing it in this case. And let's just take this example here. Let's see what that does. It should say it's not a word chain. Simple as it is. We're just checking the last index element and the first index elements by splitting them. And if they happen to be not equal, we break out of the loop saying it's not a word chain. If they happen to be equal, we have an else block which works if this loop runs without breaking, and it says it's a word chain. Cool. So that's for last week's lecture. Let's look at the few concepts that we have for this week. So we looked at functions last week. So you might have had an interesting thought uh, about functions, which is, let's say I have a function and I have a function which prints hello, simple function. So the way you would call this function is to say a test, and that would essentially run hello. But what if we have a function call inside the function itself? Let me assume that I call the function inside the function itself. What would happen then? Let's see what happens. You can see that it infinitely prints hello. I'm just gonna stop this right. Okay. I just so the code is clean. Okay. So what happened here was this statement got executed, the test statement here. When this calls, the function prints hello, but we happen to have a test statement inside the function as well. So you're not able to see anything. Is it visible now? I guess it's visible now. Okay. So by the way, if you can see this, send a message that you can see it. So we have the test case here. Okay, cool, great. So this test call here calls the function here, which makes it print hello. But we happen to have another function call inside the function. So after this statement gets run, which basically calls the function again, hello gets printed. The function again calls itself and prints hello, and this goes on forever. It's like an infinite loop, but in this case, it's not a loop, but it's an infinite function call. So when a function call itself during execution, it's called a recursive function. So a function that calls itself is called a recursive function, because this function, what it does, it essentially calls itself. So that's called a recursive function. So at the beginning, you might feel that why do we have this absolutely useless function? Because all it does is just prints hello or some infinite things so on. But you have certain use cases for this. So one major use case for this is or an interesting problem that everyone would solve using recursive function is factorial. So previously when we solved factorial, we used loops. So we had a loop which started from it had one there, and then we had to multiply this and so on and so on forth, because a factorial is essentially a factorial of 3 would be 3 into 2 into 1. So we had a loop which would start from 3 and multiply backwards and so on. We used loops, but without using loops, we can uh, calculate the factorial of a number using recursive functions. So let's see how we would do that. So it's an interesting thing. So if you understand the logic, you probably get it. So let's see. First, we'll declare a function called factorial, because that's what we're doing. And obviously, we need a number x to determine what factorial we need to calculate. So simple thing, we'll have an if statement which says if x is equal to 1, the factorial is going to be 1 in this case. We can have another statement which says if x is equal to 0 or less than minus 1 states, if it's less than minus 1, we can't calculate a factorial, and if it's 0, just return 1, but we'll just save it up for later. So if it's 1, we're just going to return 1, and if not, we're going to calculate the factorial in a unique way. In this case, we're going to return x multiplied by factorial, which is the function, and x minus 1. So what this does is, let me just first run it to see if it works properly. Let's just call, let me just print it here. Let's just try factorial of 3, we should get 6. Okay, so it works. So the way this functions is, first we've inputted 3, so x has the value of 3. X is not equal to 1, So the else block runs. So basically the else block says return x multiplied by factorial x minus 1. So let's break it down. X is 3, so it returns x into factorial x is 3 in this case, so 3 into factorial x minus 1. So substituting x here, x is 3, so 3 minus 1, 3 minus 1 is 2. So this return 3 into factorial of 2. But factorial of 2 is a function call, which means this calls the function itself. So when this calls the function, x now has the value of 2 because we're calling the function with 2 now. Is x equal to 1? No, it's not equal to 1. So it goes on to the else block. Now the else block, what it does, it returns x into the factorial of x minus 1. So basically this statement could be written in this form. Say return 3 into x, but here instead of factorial of 2, since we call factorial of 2 and x takes the value of 2, it would be 2 into factorial of x minus 1. And in this case, when we call the function, x happens to take the value of 2. So it would be 2 minus 1, and 2 minus 1 is 1. So, and this also is a function call to the whole function again. So now when the function calls, x has the value of 1 in this case. And if x is 1, we just say return 1. So we can just delete this, we can write it as return 3 into 2 into 1, which essentially happens to be the factorial of 3, and that's what gets returned at the end. So what happens is, this is a function call. So this calls the function with a number less than 1. So we have 3 now, and we compute x with 2, then compute x with 1, and so on. So in case we had 7, it would be 7 into factorial of 6 into factorial of 5, 5 into 4 into 3. So essentially at the end, if we compute everything, we would end up with 3 into 2, 7 into 6 into, and so on till 1, thereby computing the factorial of the number. So a recursive function might be a bit difficult to understand, but essentially what it does, it just calls back the function, so on. But you need to have a statement like this where you can see that it returns 1, because if I don't return a solid number or a solid data type here, what would happen is this would keep on executing like this here, because function keeps on calling itself and there's no endpoint. The endpoint here is 1. So when it's 1, it's not going, the function is not going to call itself here. It calls itself for every other value here except 1. But when the function happens to take the value of 1, it's not going to call itself. It's just going to return 1, thereby stopping the process of recursing over the same function over and over again. So that's recursive functions. I'll not give you any tasks now. You'll have certain tasks to solve in the homework to get more practice on recursive functions. So let's move into the next concept, which is errors. So I'm pretty sure all of you guys who's been coding in Python would have encountered numerous errors. So let's have a look at few of those. So let's have a let's say I have a list 1, 2, 3, and in case I happen to access the 5th element of the list, which is this. It's obvious to note that my list has only 3 elements, so indexing so calling an element of the index 5 would essentially return an error, which is index list out of list index out of range. So this is something called an index error. You can always see the error name on top here. This is an index error. So when you get an index error is when a list index happens to be out of range, because this list index is 5 and 5 happens to be out of range of this list here, because this list only has like to the range of 2 here, 0, 1, 2. So there is no index of element 5% in this list. So accessing a list with an index which is not present would return an index error. And we have another one here. Let's just have a look at a few of those. It's mathematically impossible to divide any number by 0. So evaluating that in Python would give us a 0 division error. It's a 0 division error, self-explanatory. Dividing by 0 would give us a 0 division error in any form or the other. And we have some, let's see this. So let me try adding high to 5. You do understand that high is a string and 5 is an integer, so it's not possible to add them together. So if I print this, it's going to say type error. So type error is something when two different types do not match each other, or if there's an operation or something that has to be performed, or if there's some function that needs to be performed, the type is not proper, it's going to say type error. Because see, if 5 happen to be a string, it's going to work properly and say hi 5, but 5 happens to be an integer, and it's not possible to add a string and an integer. It's clearly not possible. So that's why it's going to say type error, because both these types do not match for them to perform a concatenation operation between them. And we have another type of error, which is, let me try making xyz an integer. We've seen making, let's try this. Let's see what it says. It says value error. So value error is when so an integer, this is an integer function which converts whatever is inside into an integer. So in case I say, let me just print this here. So if we give it certain numbers as a string, it's going to convert them into an integer and print as an integer. But since this is 1 2 3, it's going to convert it easily to an integer. But it's not possible for the function to convert something like alphabets to integers, because that's not possible. And the int function can only convert certain things which have numbers in them. So obviously the value passed inside this function does not match the value that is required for this function to work on, because the value that it wants is like a list of or a string of numbers, whereas you pass the string of alphabet characters here, so it's not possible. So that's where it returns a value error. So we have all these errors. Okay, so let's just assume that we're building a program, and the program is used by some random user who just wants to use the program for their purposes, and they have no clue about what is Python, or what are statements in Python, what are errors in Python, or nothing. So suppose we have a small bug in the program, and when suddenly our program has some way that some form or the other the program divides by 0, and the user using the program sees this big scary error here, because he or she will not understand anything out of seeing all this, and maybe like seeing this, because the user does not know what the statement means or what type error or any of these error mean. So that's when we have something called a try catch block. So let's see how that functions. So let's just take the example here. This is clearly an invalid statement because it returns an error. So it's not possible to execute the statement in Python. So how a try and except works is, we have a try statement. This is the syntax of a try and except block. We have the try. So we try to execute this statement. We're trying it. We're just trying to see if it works or not. So hence the phrase we try. So we try this. So in case this returns an error, that's when the except block comes. In case this returns an error, we say this operation can't be performed. So let's try printing this. See, so for a user using the program, the operation can't be performed makes sense, rather than a huge input or some traceback most recent call value error and so on. This is more user friendly for a user to see, rather than this big scary statement here, because the user now can understand, okay, this operation can't be performed, I got it. Plus one thing that happens is it does not break your program does not break in between. For let's example, I just print something. So the program does not break. In this case, if I try to print hello after this, it's not going to do it, because the program stopped here itself. The program stopped executing right here, so any statement that's below is not going to run. Whereas with this block, what happens is we try these statements, and in case it returns an error, we just say the operation can't be performed, and the program runs as usual. There's no interruption to the program. We just try this, and the program does not break or give some big scary error in front of the user. So this is how the try and except block work. The statements under the try block is tried to execute, and in case it returns an error, it moves the except block directly, and the statements under the except block gets run, and after that it executes the program as per normal program flow. But the except block has an interesting property, which is you can specify which error and what message that you want to send to each error. So let's try this one here. Maybe let's just try the type error here. So I want to try concatenating a string to an integer, and we clearly know it's going to return what an error, which is the type error here. This is the name of the error, so you have to make note of it. So it's the type error here. So you can same except, and we just say print this operation can't be found. Okay, so this does give a sort of a message, but what if we want to display different messages for different errors? So that's when the except block has a special uh, syntax to it, which is you can include errors that you want specific output to be given. In this case, the error that is returned is a type error, so I can just type except type error. To be noted, it should be type as it is, because T is caps and E is caps without a space, so it should be typed as it is, so that you don't mess up the error type. So instead of giving this statement, let's just say uh, the two types can't be concatenated. You can say that. So in this case, it's just going to say the two types can be concatenated. But what if there happens to be something else, like I happen to have an error like this? It's still going to say the two types can be concatenated, but let me just remove this statement here. So as you know, this is a value error and not a type error. So what happens is, since this except blocks only runs for type errors, because you specified only if there is a type error, print this. Otherwise, we don't have anything to execute. So it's going to say, it's going to print this big scary error here. So we can even have a general except block which just says something went wrong. So in this case, this happens to be not a type error, so this statement is not run. But since this happens to be, the except blocks catches any error that's thrown, like it doesn't have to be type error or anything, because if you don't specify a particular error, this statement here is going to catch any error that is thrown, and it's going to print the statement under it. So since this is a value error and not a type error, this except block will not run, whereas this will run because it's a general saying that something went wrong. And so if I happen to have, like, let me just try printing hi with 5, this is a value error, so it should print the two types can be concatenated and not print this, because the specific error type is specified here. So this statement would be run because we've specified the error type here, so this would run because this happens to be a type error. There is no need for this to run because the error has already been caught and this statement has been executed. Okay, so let's just say now we understood that we have a try statement which tries to execute a certain command, and if that does not work or if it returns an error, we have an except block which catches the error and prints a certain message that we want it to display. We can catch specific errors by adding the error type here, so that we have we have specific messages for each error, so that the user knows which error is being caught. Let's just say I could add I could try this and have an except statement say except 0 division error, and say you can't divide by 0, so that we know that the user or someone is trying to divide by 0 and that's not possible, rather than giving this whole error message here. So you can add specific error types so that you give specific messages and specific errors are caught. And at the end, you can always have a general statement. So in case you have an error which is you have not specified or a message, it's just going to say a general message which is something went wrong in this case. So the user will know that oh, okay, there's some problem in it and there's something that's gone wrong. Okay, so there's one bit of modification that we can do to this statement, which is, what if I want to try a statement, and if it does not work, I want to say that I want to specify a message, and if it does happen to work, I want it to print something. So in that case, let me try a is equal to 5 plus 5. Perfectly valid statement. There's going to be absolutely no error that is going to be returned here. But just in case, I have an except block here, so that a big scary error does not pop up, because I don't know what error will be thrown. So as a developer, I'm just having a general except block which says something went wrong. So it's just going to try and it worked properly. So there is, you could add a statement, the else statement here, and let me just try printing a here. So it perfectly prints a because this is completely a valid statement and it prints a. This statement is not printed because there is no error for the except block to catch. So let me try this and let's see what happens. Cool. Now you see what the difference is. It's not possible to add strings with integers as we saw, and since it would return a type error in this case, this except block catches the error and it says something went wrong. But as soon as the error comes, this statement is not run. You might have certain programs that you might build in the future, whereas which, if there is an error, you want to stop the program right there and you don't want the program to execute after that. So that's when the else block comes into use, where you have certain code that you want to run. You don't know where the error is going to pass because you as a developer would have a lot of different code. So at you deploying your project to software, errors can occur at any point of time. So it's better to have a try block and an except block which catches the errors. So if there happens to be errors, you wanted to print some specific message that you've been added already, and if it does not catch any error, you want the program to run as usual. That is when the try except and else block comes in hand. So you try a certain set of statements, and if the statements happen to be valid, the else block runs. If the statement do not happen to be valid, the except block catches the error and prints the error. So this is not a valid statement, so it says the error, and whereas this is a perfectly valid statement, so it's just going to print a. The reason why we need an else block is, you could ask, why not give this print statement here? Why do we need an else block? So if it's a valid statement, it's going to work properly. But let's just say in this case, it does say something went wrong. But the point is, having an else block makes it much better, so that you have certain code which you're not sure will run, and if that happens to work properly, you can always go ahead with that thing. So that's when a try except else block would, like statements like print statement and all that, where you print variables, are probably very unlikely to return errors in this case. So you can probably have them in else block, and you have certain code which you're not sure and might return errors, which you can put them in the try block. So that's the try except and else. There is a certain command which complements this here. So to summarize this, a try statement tries something. If it has no errors, the else statement will run. If it has errors, the except block will catch it. There's something similar to it, but with slight modification, which is, let's try printing x, and let's have an except block, which is, say, print something went wrong, and a finally block here. I'll explain you what the finally block does soon. Program is finished. Okay, let me just declare x to be 10. Let's just run this program. So it prints 10. So x is 10, perfectly valid statement. We print x, which is also a perfectly valid statement. And since there is no error, this block does not run. But surprisingly, we have something called finally, and a print statement runs here. Okay, so to see what's the function of finally, let me just cut off this x here, and or the declaration of x, Let me try printing. So I think okay. So I have not declared a variable called ABC. So thereby it's going to return an error. By the way, if you want to check what error is this, let's just print. Uh, so it will return a name error. A name error is when a certain variable is not defined. So in this case, the variable ABC is not defined. It's a variable. Don't mistake it for a string. If it was a string, I would have double quotes. It's a variable. So ABC, a variable is not being defined, so it will return a name error. Since it returns a name error, the except block will catch it and it prints something went wrong. But there's something unique about this program, which is the finally block also executed. So the finally block is, you could say that even if an error is caught and it's printed, the finally block will still run. So whereas the else block is to differentiate between both of these. If it's a perfectly fine code, the try block will run, the else block will run. If it's a perfectly fine code, in this case, the try block will run, the finally block will run. But if this try block has an error, the error will be caught in the except block here, but the else statement won't run because an error has been caught. But in the finally, with the try except finally, if the statement returns any error, the except block will catch the error and the code under the error will under the except block will get printed, but also the code under the finally block will also get printed, whereas in the else case the code won't be printed. So that's the difference between an except block and an else block and a finally block. To summarize this lecture, we saw about recursive functions, which is when a function calls itself inside a function. Then we talked about a few errors. The index error, which happens when a certain index is out of range. A zero division error when you try to divide by zero. A type error when two different types of concatenator or any operation between them is performed. In this case, the string is concatenated to an integer, which is not possible. And then we have a value error when a certain invalid value is being passed, and that returns a value error. And we also saw a name error, which is when a certain variable is not defined. And to work with the errors, we saw something called the try except block. So the try block, you essentially run the code that's under the try block. If it has an error, the except block would catch it and print any certain statement that you want, so that we don't get some big scary error statement here. And you can accept specific error types so that you can have personalized messages for each error type that you want, so that it makes much more clear which error it is. So even you as a developer, it would be much easier to see what error and what went wrong if you have like personalized the messages for each error. Then we saw the else and finally block. The else block does not run when an error is there, whereas the finally block does run when